Now, thank you. Now, the love boat travels at a rate of 30 kilometers per hour in still water. If it can travel 45 kilometers upstream in the same amount of time that it takes to go 63 kilometers downstream, how fast is the current? And we have already discussed the most useful thing here to do is to make a table. This table is the closest I ever want to get to lattice. So what will I label my rows? What are the variables for my rows here? All right, Yvonne?
Up and down.
Upstream and downstream. All right, so let's fill in the parts that I know for certain. What is my distance downstream? Yvonne? Sorry, what is my...
Downstream 63.
Downstream is 63. Levi, what is my rate, or what is my distance upstream?
63. No, 45. Sorry.
That's okay. All right, so now the time. So do I know what the time is? Do I know how long it takes me to make this run up and downstream? No, it does not tell us. No. So it doesn't tell us the time. So what are we going to use instead of a number if I don't know what the time is? Yvonne?
T.
T. T for time because I don't know what it is. All right. So now we get to the tricky part. Now we have been describing the rate of the overall boat, that is its ability to go a certain speed plus or minus the current. We've been always writing the rate as the rate plus the current or the rate minus the current, right? So given these, what is how fast can the boat go in still water? Mia?
Like the 30 plus.
Yeah, we can do the whole thing here. So what's going to go in my upstream column?
30 minus C.
30 minus C. Because I can go 30 kilometers per hour in still water, and I'm going upstream, so that's mean the current is going to be slowing my progress. What goes in this box here? What goes in my box right there? Sevi? 30 plus C, because the 30 kilometers that I can go in still water plus the current that is pushing me down, up or down the river or up and down the coast, whatever. Okay, so what do I do with rate and time to get distance? Start with very basic, easy things to do. What do I do with the rate and the time to get distance? This is not a trick question. Quinn?
Multiply.
I multiply them. So what am I going to do to these two boxes to get the third box? Multiply them. So I have 30 minus C times T is equal to 45. What's the other equation that I'm going to need? Sophie?
30 plus C times T is equal to 63.
Okay, what am I going to have to do with both equations so that I can go ahead and solve these things? Charlotte? Distribute. I'm going to have to go ahead and multiply these things out. So go ahead and do that and get two simpler equations. So go ahead and do that. All right, so you should be getting an equation that is ready to solve here. All right, so what does this equation equal?
30T minus CT is equal.
Okay. What does my bottom equation simplify to? Anna?
30T plus CT equals 63.
And look at this. Isn't it convenient that the CTs are opposites? So if I add them, if I add these two equations, my CT will cancel out, and I will end up with 60 T is equal to 108 divided by 60 divided by 60, and I get T is equal to 1.8, I believe. So time is 1.8. 1.8, so that's 1 hour and 8/10 of an hour. So do I have my solution? No. We want to figure out how fast the current is. So that means I have to plug in my T into my equation. So I have 30 minus C, and I could use either equation, times 1.8 is equal to 45. So go ahead and solve for C. Go ahead and solve for C. And you will get an answer of 5. The easiest way to do this is to divide both sides of the equation by 1.8. So you get 30 minus C is going to be equal to 25. Let's just go ahead and do it. So we have 30 minus C is equal to, and we do 45 divided by 1.8. You get 25, there you go. And so you get negative C is equal to negative 5, therefore C is equal to 5. Oops, that's not what I wanted.